All right, let's go and start 2.2, basic differentiation rules and rate of change. So today's objective, find the derivative A of a function, derivative of function using a constant rule. The constant rule means the function is constant, like a y equal to 3, y equal to 10, okay? Next one, find the derivative of a function using power rule. Okay, and then find the derivative function using a constant multiple rule, and find the derivative of function using a sum and differential rule. Okay, and then find the derivative of a sine function and a cosine function, and find the derivative rate of a change. So today we're gonna do we're gonna go over some rules how to find derivative of a constant function, and then just regular function. We're going to add those derivatives or subtract those derivatives. We can do all that. So let's look at the constant rule first. The constant rule is the easiest one to do. So you know what constant rule means? So constant rule means you're taking a derivative of a constant function. So remember we talked about yesterday that the derivative is like a rate of a change, right? You're going to look at how much does y changes while the x changes. Remember, like if I'm looking at my function graph, like that, you know, x1, x2, y1, y2, I want to know the change. So it's called dx, dy. So you're gonna say slope is y2 minus y1 over x2 minus x1. Well, we can also write down as f of c plus delta x, if I call this to be c, minus f of x over delta x. And then I'm going to take the limit of that. Okay, so, but if the function is a constant, like this over here, like a y1 and y2, y1 is same as y2, so there's no differences, right? Okay, so which means if I do y2 minus y1 gives me what? 0. That is why constant rule says derivative of a constant function is always 0. So that's the easiest thing. You like constant rule. You like constant function because your constant function, it doesn't change. You don't have any change. Okay, just think about this function right here. All right, say this is equal to 3. You're looking at any point in here, it doesn't matter which x. Let me erase this part. It doesn't matter which x you're looking at it. I'll call it, this is equal to 1, 2, 3. I'm going to call this to be. If I'm looking at x equal to 1, what's my y equal to? 3. If I'm looking at x equal to 2, what's my y equal to? Again, 3. So this is 1 comma 3. This is a 2 comma 3. Again, this is 3 comma 3. There is a 4 comma 3. Y value is always 3. There's no changes, right? It's a constant. That's why when you look at the derivative or slope, you get y2 minus y1, everything. Everything over x2 minus x1. Numerator is some number. Numerator is 0 always, and denominator is some number. That is why it's equal to 0. So derivative of a constant function is 0. So in other words, derivative of this y equal to 7, as you know, slope would be then. So slope would be 7 minus 7, and then some number, which is 0 of a number, which is 0. So derivative is 0. So just memorize it, okay? So if it's a constant function, your derivative is 0. So like this, derivative is 0, derivative, the function is equal to s of t equal to -3. There was no t there, just -3. Okay, this function is -3. right here. And this function is a 0. This function is a 7, right? So it's always 0. It does not move. When your slope is 0, when you have a horizontal line like this, your slope is 0 because you're not moving. Your y does not change. Same thing over here. Okay, k is a constant. Pi squared is also constant, so it's a number. So again, the derivative is 0. All right, class, look at this one. Do not get confused. K, they told you it's a constant. K is a number. And pi of square is a number. 3.17 to the square. That's what that means, right? That's a number. So that is why the derivative of that is a 0. Now let's look at the power rule. The second simplest one is a power rule. So power rule means, yesterday, do you remember when you take a derivative of, let's look at this one. So I'm gonna look at yesterday's lesson that we did together. You f of x equal to say 3x plus 4. Let's take the derivative of this, okay? So what do you get? We're going to do the definition by derivative using a limit process. That means f of what? X plus delta x minus f of x, everything over delta x. That's what we have to do. So we're gonna find, just like we did yesterday, step 1, I need to find f of x plus delta x, right? Then I'm gonna look at this, that's my function, but I'm gonna replace x with the delta, x plus delta x. So I have 3, and then I'm gonna put what? X plus delta x, because that's what I'm gonna put it in. Now I'm gonna replace with that, right? And then what do? Plus 4. So if I, and then step 2, we already get that one. Step 3, so we're gonna put that in. So this is the same as, I'm going to just rewrite this one. This is the same as 3x plus 3 delta x plus 4. So let's do our limit. So that means f of x plus delta x minus f of x, everything over delta x is the same as limit. I'm gonna put that in, right? 3x plus 3 delta x plus 4. And then I'm gonna do that one, which is minus 3x minus 4. Everything over delta x. And you're gonna say, let's cancel out the ones that we have. That and that cancel out, that and that cancel out. Then we have limit delta x goes to 0. We have a 3 delta x, everything over delta x. And again, we can cancel out that and that have just a 3. Okay, so now let's look at this. Let's go over this. So this is what we found. What happened to, what is your f prime? Just simply equal to what? 3, isn't it? So this is a formula. This is called power rule. Power rule means you look at this. Okay, this is what you do. Derivative of a function. I will call it a x to the n. Okay, the derivative of that is equal to a times n times x to the n minus 1 power. That is a power rule. That's the definition of a power rule, which means for our case, what is my n for this case? My n is 1. I'm looking at this problem right here. Okay, look at this problem. My n is 1, a is 3, right? So if I use this power rule, then I get f prime is equal to a times n times x to the what? 1 minus 1, right? And then next one plus 4 times 0 times, I don't have anything, right? There's not, remember actually this 4 right here, you know right away the derivative of a constant is what? 0, so I don't even have to do that. So I can just simply put what? 0. This is by constant rule. Okay, and this I'm gonna use power rule. Okay, so 1 minus 1 gives me 0, so this simply gives you 3 times x to the 0 power, which is same as a 3. X to the 0 power, anything to 0 power is 1. So that is a power rule. Let's look at another example. So if I give you this, so this time I'm not gonna use the limit process. I'm just gonna use a power rule, okay? So let's look at another one. So if I give you a problem like that, okay, can I change the problem to actually, I wanna change this into the different number. Okay, this is what I have. Let's take a derivative of this. If I use this one, okay, if I do the limit process, it will become a very long problem, but I'm just gonna use a constant rule and a power rule. So right away, I'm gonna do the easy one first. This become a what? Simply 0. So when I take a derivative of this, okay, then I'm gonna take that become a simply 0 by what? Constant rule. Okay, is everybody with me? Next one. What does the power rule says? You multiply power with the what? Coefficient. So I will have 3 times 4 times x to the, I had 4 power, but now what I'm gonna do what? By the rule, the power rule says you subtract 1 power. That's what you have. What's next one? Somebody tell me what's the next one I need to do. 5 times which number? I'm doing this one now. 5 times what? Can somebody tell me what's the 5 times what do I need to do? 2, that's right, the ABN, that's exactly right. 5 times 2 times, okay, x to the 2 minus what class again? 1. Okay, what's next one? So I'm gonna do 3 times. Can somebody tell me 3 times what? I'm doing it this one now. Anybody? That's right, 3 times 1. Why? I don't see any power, but that power is 1. So 3 times 1, x to the 1 minus 0. And of course, there's the last one is 0. The positive 7 is the easiest one, right? The constant is always, the derivative of a constant is always 0. So that's why I just put the 0 first. So now let's just simplify this. 3 times 4, 12, x to the 3rd power, 4 minus 1 gives me 3 power, plus 5 times 2 gives me 10, x to the 1 power. Next one is 3 times 1 is 3, and x to the 0 power, that 0 is a 0. So I don't even have to write down this anymore. By the way, does everybody see that? A 0 power is the same as 1. So I simply have 12 x to the 3rd plus 10x plus 3. So I'm done. So that is my f prime. The power rule make your life much easier because you don't have to use the limit process. But yes, you have to learn that, okay? But now you're going to have this simple tool that you can take derivative easily by using a power rule, okay? So let's look at another example. But if I give you with the fractions, how would you do that then?
Miss Harris.
Yes.
Okay, can you go back up?
Yes.
Okay, you see where you say you got 10x 1 plus 3x. Was that power 1, 2?
Look at this one. X, oh, this is x to the 1, excuse me. Thank you.
Oh, okay. I get it now.
Sorry about that. Thank you for catching that up. Thank you. Thank you. Let's do another example. How about if I give you problems like this? I want to take a derivative of that. Okay, this one is not that simple, isn't it? Because the last problem, look at everything. My power is in the right here, in the numerator position. What I mean is everything over 1, everything over 1, everything over 1. So everything was in the numerator position. But look at this one now. This is not same. So this case, first thing you need to do, you look at individual one, make sure everything is in the what? A power, okay? Not radical, not in the denominator, but it's just in the simple power in the numerator position with the power. So first thing first, I'm gonna rewrite this problem. So this is what I need to rewrite, and this is what I need to rewrite. Okay, so this is what I'm gonna do. I'm gonna rewrite this problem, 3x squared plus, I'm gonna write down as 4x to the, somebody tell me what power do I need to put? I'm rewriting 4 over x to the third. I wanna rewrite it as just the x to the some power. Since 3x to the third in the denominator, I'm moving into the numerator, they become a what? -3. All right, let's do next one. This, the square root of x is a radical, but I want that to be something to the power. So I need to rewrite that as x to the what power? Somebody, what is the what power? What is the radical power? That is same as what? 1/2. And then just write down 4. So does everybody see that? I just rewrote my problem so everything is in terms of a power, not radicals, not denominator, but everything is in the numerator position with a power. Okay, pay attention. Everybody look at this one because that's what you have to do with your homework problem. Make sure you rewrite your problem so you know how to use a power rule, because a power rule says a to the n, a to the x to the n. As you see it, the n is in the a, it's just some coefficient, there's an x, I want that to be what? That to the n power. Then I know what to do. That means a times x, a times n times what? N minus 1. That's how you take first derivative using a power rule. Now, let's take a derivative of that. Okay, I'm gonna do easy one first. What's my easy one? That one, right? That one simply become a 0. And then this is also easy. Let's do this one. What's that equal to? 3 times 2 times x to the 2 minus 1. Okay, let's do the next one. Let's do this one. What is that equal to? That's also easy now because we already rewrote it. 4 times -3 times x to the -3 minus 1. All right, let's do the next one. That would be, you know, there's a 1 there, right? So 1 times 1/2 times x to the 1/2 minus 1 and plus 0. Is everybody with me? Okay, just the simple addition and subtraction, that's what I'm gonna do. So by doing that, I see it 6 to the, excuse me, I'm gonna use the same color. With 6 to the x to the 1 power. What's next one? This together gives me negative 12, so it'll be negative 12 x to the negative 4 power. Negative 3 minus 1 gives me negative 4 power. Next one, the 1 times half gives me still half. X to the what then? Negative 1/2. 1 minus this one right here. 1 minus 1/2 minus 1 gives me negative 1/2 power. Plus 0. So I'm not going to worry about plus 0. 0, that's 0. I'm not going to worry about it. I can just erase it. All right, I'm done. I just need to rewrite this problem again. I need to rewrite it like this. I need to rewrite it like this. Okay, I need to rewrite it like this. So that means f prime is, so my f prime of x is 6x minus 12x to the 4. I made this negative 4 moving into denominator become a positive 4. All right, same thing. That's what I'm gonna do, plus 1/2 square root of x. Does everybody see it? This goes to denominator. This is the same as 1 over x to the 1/2. That's the same as 1 over square root of x. That's how you got it. All right, so you're done. So when you do your homework problem, you need to make sure you need to rewrite your problem, change your power to what looks like this. Okay, you need to make sure your function is a times x to the n. Okay, then you know what to do, a times n times x to the n minus 1. That's the power rule. Okay, so I'm gonna go back to your lesson so we can finish up. So this is what they're talking about right here. They have some examples, which we've been doing it. Okay, make sure that you write those problems. So they're giving you how to do, if this is a problem given like that, you write it like this, you rewrite it, and take a derivative, and then you write back to what it looks like this. Okay, simplify it. And then constant, a multiply rule, yeah, we already know that, we've been multiplying that. So we have done all those similar ones. So no big deal, we have done that. And then now, sum and difference rule. I can add 2 derivatives and I can subtract 2 derivatives, no problem. Like we've been doing this, we have done that kind of problem. We have done problems like that. Okay, let's look at this kind of problem right here. This is a good problem. Let's try that one. That's the one that I haven't done with you guys. Okay, so if I give you problems like that, if I give you problems like this. If I give you that, okay, the first thing you need to do, again, we need to rewrite this problem individual term. Right now, they're combined as one denominator with the 3 terms in the numerator. So you need to rewrite this problem. So you need to rewrite it as 4x to the 3rd divided by x plus 2x divided by x minus 4 divided by x. Then you know what to do. Because this kind of problem, you know what to do. You can just simplify it and then you can take a derivative. So now let's simplify first before we take a derivative. Then you're gonna say, okay, that and that cancel out to be x to the square. And that cancel out, there's nothing there. So I have 4x squared plus simply 2. And then minus, remember this is 1 power. So I'm gonna rewrite it as 4 to the x to the negative 1 power. Okay, are you following me, class? Any questions so far? You need to rewrite your radical problem, okay? Make it into individual term, and then you simplify it. This is what I did. You simplify this. This means what? You need to rewrite it as an individual term. Oh, simplify here. Now we can take a derivative. All right, let's take a derivative. So we're gonna do I have 4 times 2 times x to the 2 minus 1 plus, this is an easy one, that's become a 0. That's your constant rule. And then plus, excuse me, minus. Minus 4 times minus 1 times x to the negative 1 minus 1. Okay, I'm taking a derivative of individual terms. That is this, and this is that. All right, so we're done then. Just need to simplify it. 8 x to the 1, 0 is 0. I'm not gonna worry about it. And negative 4 times negative 1 gives me positive 4 x to the negative 2 power. Okay, I need to do one more time. I need to simplify one more step. Okay, so because of this, okay, so that means my answer is 8x plus 4x to the square. That is my f prime. So my f prime of x is simply 8x plus 4x squared. All right, any questions so far, class? So when you take a derivative of that, this is what you get. Okay, now, any question you have? Anybody have any questions? Okay, and make sure that you guys put your name, say I am here, so I know, so I can do your attendance. Because I see 5 people did it, but not everybody, so just make sure that you all do it. So I know you're here. And then derivative of sines and cosines. This one, I want you to, it just makes sense, okay? Derivative of a sine. Just think about if you graph, I'm not gonna even use my notepad, just use this one. If I take a graph, okay, this is a sine graph. So when I take a derivative of that, my derivative is like this. So if you graph, your graph looks like that. Okay, so this is a cosine of x. This is a sine of x. So in other words, when you take a derivative of a sine, you get a cosine. And when you take a derivative of a cosine, you get a negative sign. All right, you can just memorize. Okay, so derivative of a sine is what? Cosine. And derivative of a cosine is what? Negative sign. Okay. So we can do it. So take a derivative of that. Take a derivative of sine x, which is what? Cosine x, and just multiply by what? 2, because you have 2 in the front. And derivative of sine x over 2, which means I can rewrite it as 1/2 times sine x. Derivative of sine x is again what? Cosine x. So I have an answer right there. You can write it down like this, whichever. Okay, this is a composite function. You have an x and you have a cosine. So take a derivative of x would be what? Simply 1 times 1 times x to the 1 minus 1, which gives me 0, just simply gives me 1. Derivative of a cosine is what? Negative sine x. Does everybody see why derivative of x is 1? If I give x, what's the derivative of that? That means what? There's a 1, there's a 1. So 1 times x to the 1 minus 1, which gives me what? 1 times x to 0, which is simply what? 1. So that's another easy one. If you have x as your function, your derivative is simply what? Just the 1, simply 1. Okay? So that's why you have the derivative of x gives me 1. Derivative of a cosine gives me negative sine x. Cosine, derivative of cosine is negative sine x. Derivative of sine x is what? Cosine x, but you have a negative in the front, so we got negative in the front, negative there too. So make sure that you memorize that. The rate of changes. Okay, you have seen how the derivative is used to determine slope, which we did it yesterday. Derivative can also be used to determine the rate of a change of one variable with respect to another. Yes, we know that because remember, m equal to dy divided by dy divided by dx, right? One variable with respect to another variable, yes. Applications involving rates of change occur in wide variety of field, which is true. When you look at when you take your physics class, you will see that all the time, velocities and accelerations. So a few examples of population growth rates, production rates, water flow rates, velocity and acceleration, that's all real example of derivative, okay? That's why calculus is important. So we're gonna look at that. And also, when you have a common use of a rate of change that we use is describing motion, an object of moving it in a straight line. And then also we can do use either horizontal or vertical line. Designate origin to represent the line of motion. If you move to the right, we usually call it positive. If you move to the left, we usually call it negative. And then we can also do up and down. If you move up, we call it positive. If you move down, we call it negative in motion. Okay, because you got to have a direction so you know which one is up and which one is down and which one is positive and which one is negative. So this is the way that we do. Anything move to the right or up, we call it positive. Anything move to the down or left, we call it negative. So the position function, okay, position function, when you take physics, you're going to talk about position functions, you're going to talk about velocity functions, you're going to talk about acceleration functions. So we're doing that in a way. So I'm doing in a way that you will use in your physics class, okay? So the rate is the rate, or I can tell it average velocity, whichever, okay? The rate is distance divided by time. So we can say changing in distance divided by changing in time, we call it average velocity, because you're gonna look at how much it's changed, how much the y direction, the position changed, okay? Plus compared to how much the time changed. So let's look at this problem. This is a position problem. S, so this is actually, I can rewrite as S of t, the function of a t. All right, so negative 16 t squared plus 100. This is a position function they gave you. All right, so a ball is dropped from the height of 100 feet. So if I say this is my building, and this is 100 feet. Okay, and this is my building. All right, and the ball is dropped. Okay, and this is my position function. So where S is measured in feet, and t is measured in seconds, find the average velocity over each of the following time intervals. So I want to find, so according to this function right here, it says changing in time, changing in distance, and changing in time give you average velocity. So I can do this problem. So I can say, okay, I need to find average velocity, which is what? Changing distance divided by what? Changing time. So I'm gonna do S of 2 minus S of 1, everything divided by what? 2 minus 1. I'm doing an A1 right now. So you're gonna say, okay, that just means negative 16 times 2 squared plus 100 minus negative 16, 1 squared plus 100. Everything divided by just simply 1. So when you finish up, then you get what? Right? So then you have, and that cancel out. So when you simplify this, you get one number. According to this, you get this number. Okay, so in other words, it's moving which way? Downward, because I know this is negative. Okay, is everybody with me? They gave you a calculation. Negative 1, this give you 84. When you multiply 2, you get 36. That's what 36 minus 84 divided by 2 minus 1 give you this number. The one that I didn't finish over here, you get a negative 48 over 1. Okay. So you would do the same way for other two problems. So 1.5, you get 64 minus 84, and you get negative 40 feet per second. Another one, 1.1, you get negative 33.6 feet per second. So what do you see? Let's just think about for a minute, okay? So I had S of 2, S of 1.5, and S of 1.1. The difference, this one was negative 48 feet per second, and this was what? Negative 40. The other one is negative 33.6 feet per second. So what can you tell? What happened to your speed? Okay, when you were right here. Okay. Okay, this is, I'm looking at the average changing distance. Okay, so at 2 seconds later, like I said, this is about 1.1 second. This is 1.5 second. This is 2 seconds. So their speed is what? Increasing, isn't it? Because you had negative 33.6, and here's negative 40 point something, negative 40.8. So average velocity is increased. Okay, it's going downward, but still it's increased, getting faster, in other words. All right, now next thing. A velocity, which is velocity is the same as first derivative of your position function. See that? Velocity is the same as derivative of your first derivative of a position function. So you know what to do, how to do it. All right, next thing. The velocity is a derivative of the position function, and velocity can be negative, 0, or positive. Like the last problem that we had, all these are negative, which is fine. That means it's going downward. Okay, so velocity can be negative, okay, and positive, and can be 0. 0 means you don't have any velocity. But let's listen to speed. The speed is the absolute value of a velocity. So speed cannot be negative. The speed is different from velocity, okay? Velocity can be negative, 0, or positive, because you can move upward or move downward or it doesn't move at all. What the speed means is the absolute value of a velocity. So it only can be either 0 or a positive number. So like a speed limit, just think about the speed limit. Your speed limit is like 70. Okay, nobody says your speed limit is negative 70. Okay, it doesn't make sense. Okay, so speed is absolute value of a velocity. So you will have only 0 or a positive number. Okay, next one. So position of a free falling object. The free falling object, this is your equation. -1/2. G is a velocity. G is a gravity. Okay, T squared plus V naught means initial velocity. S naught means initial position. Whenever it's put the naught, like 0 here, that means initial place, initial position, initial velocity. That's what naught means, okay? So S naught is the initial height of an object. V naught is the initial velocity of object. G is acceleration of due to gravity. I gave you what that means. On Earth, the value of G is approximately 32 feet per second. If you want to do a feet per second, it's 32. If you want to do a meter per second, you do 9.8. Okay, you get 9.8 meter per second square, or you can do 32 feet per second square. That's your gravity. It's just different unit. It's the same thing, but different unit, okay? So here's example of that. At time t equal to 0 seconds, a diver jumps from a platform diving board that is 32 feet above the water. So look at the figure. The initial velocity of the diver is 16 feet per second. When does diver hit the water? What is a diver's velocity at impact? So I need to figure out two things. When does diver hit the water? So I need to know the time at here. What is my time? Okay, and I also like to know a velocity at this time. Two things I want to know. Okay, so next thing we need to figure out, remember they gave you equation, S naught, ST is equal to 1/2 GT squared plus, what do they want you to use? Okay, and V naught T plus S naught. That's what they gave you. So I'm gonna use that and I'm gonna just change into whatever they gave me. So they told you their unit they're using is what? 30 feet. 32 feet, they didn't give you meter per second. So I know right away I can change this into 32. And I can also change that into what? What was the meter per second? Right here. So I can just change that into also 1/2 32 T squared. Okay, and what is my velocity right here? Initial velocity, they told you diver jumps from the platform diving board 32 feet above the water. Initial velocity is what? 16 feet per second. So I also know what this is. That's 16. So I got it all then. I have 1/2 times 32 times T squared plus 16T plus 32, or I can rewrite the 16T squared plus 16T plus 32. That's my position function. So your homework problem, they are not going to give you any formula because they expect you to know this. Okay, they expect you to know this because this is like a very common formula for almost everybody knows. I guess if you take physics class, they will know this one. Okay, you will use this one. So you need to know your position function is always like this: -1/2 GT squared plus V naught T plus S naught. And then you need to figure out what to put it in for V naught or S naught and G, okay? The G depends on what kind of units you use. Since they told you they're using a feet per second, that's why you are using that. So this is how you got here. Does everybody see how you got this? So we got this because of the given information. They told you it's a 16 feet per second. They told you that. And they also told you the initial height is 32 feet. So we get all this information. Now, next thing. Remember, we want diver to come down here, touch the water. I need to know what that T equal to. I gotta figure out that what T equal to, but my position used to be 32. But when you come down all the way here, what is my position? Position become a 0, isn't it? Look at this one, look at this graph. Right now, this height is 32. But when the diver come down all the way here, what is my height? The height is what? Will be what? 0. Over here, this height is 32. But over here, the bottom part where the diver touched the water, the height is 0. So that is why you set this equal to 0. Okay, because you know your height is 0. The height used to be 32 feet, but the diver jumped down and come down to where you touch the water. When you touch the water, you don't have any height. Height becomes 0. So this is the same as that height is 0. That's what that means. Okay, now we're gonna do factoring. So looking at all this thing, or look at this equation, the common factor is -16. So you bring out the -16. So you have t squared minus t minus 32 equal to minus 2 equal to 0. All right, and then you're gonna factor this, which gives me t plus 1 and t minus 2. -16 never can be 0, so if you just divide it by -16, you don't have anything, then you have a t plus 1 and t minus 2 equal to 0. So it'll be t plus 1 equal to 0 or t minus 2 equal to 0. That's why you have this. Okay, this is a time. I cannot have a negative time, so my answer has to be only this. So if here time equal to 2 seconds, the diver would touch in the water. Okay? At t equal to 2 seconds, the diver was staying in the 32 feet with the initial velocity equal to 16 feet per second. 2 seconds later, the diver will touch the water. That's what they say. We figured out because we know calculus. Okay. So now, since I know that, okay, then I can figure out what the velocity is. Because remember, you have S. That's your velocity, that's your position function, right? So I'm gonna take a derivative of that. So derivative will be what? S time of t, or I can just write down as a vt, whichever, that's the same thing. And I'm gonna say, okay, I will do exactly like I've been doing, 16 times 1 plus 16 times 1 times 1 minus 1. The constant is always 0. The constant function, derivative of constant function. That's what we have. Maybe 32. Here. Okay. Now, it says they want to know what's the velocity at the impact of touching water, right? So I'm plugging in 2 as my t. So -32 times 2 times 16, which will give you -48 feet per second. So when this person dive down here, right here, the velocity over here is -48 feet per second. That's pretty fast. Yeah, pretty fast. Okay, any questions so far? Everybody good? Let's go to the homework problem because I want you to do some homework problem. All right, so let's go over your homework. Everybody can see right away, right? The constant function is the favorite thing to do because it's very easy. It's just simply 0, right? Everybody agree? It's just simply 0. Okay, okay, like this kind of problem. I have to rewrite this problem first, right? So I'm gonna say, okay, let me rewrite it. That means the same as x to the 1/9 power. This index is your denominator of your power. It's a 9, so it's the same as that. Then I can just take the derivative of that, which is, remember there's a 1 in the front, so 1 times 1/9 times x to the 1/9 minus 1. That is the same as 1/9 x to the 8/9, right? Whenever you have a denominator, make a common denominator. So it'll be 1/9 minus 1. You can just rewrite it as 1/9 minus 9/9, which will give you negative 8/9. Just think about that, okay? So note. Rewrite this one, so it'll be 1/9 x over what? 8/9, because we want to put your power as a positive number again. So that is why you have this. It's an easy one because pi over 2 is pi over 2, and derivative of a sine is what? Simply what? Cosine. So you're done. This problem again, don't do this on anything yet until what? We write this problem. So this is the same as 7/x to the 1/3 plus 6 cosine x. And then you're going to say, okay, I don't want to put my power in the denominator. I want to put that in the numerator. So that we come on x times x to the negative 1/3 plus 6 cosine x. And then you know what to do. And you can take a derivative of this. I'm not finished, but you can finish it by yourself. Okay, this is a very good problem. So I'm debating now or tomorrow. How many people want to do this problem now? Raise your hand. I cannot see your hand actually. All of you guys only showing your. How many people want to do now? Raise your hand. Because you have to do this problem anyway tomorrow. So let's look at this problem together. Okay, somebody needs to kind of memorize it, what we're doing, so I can use my notebook to do it. Okay, so remember, let's look at this problem to figure out what's my position function first. Can everybody read it? Okay, a silver dollar is dropped from the top of the building that is 1,353 feet tall. So I'm going to draw myself a building. Important part, it says a fit, so we know what to use. Okay, so what does this mean? That is my what? S0, right? My initial position is 1,353 feet. I can request 300. Does somebody have a question for me? Next one. I got to figure out what my V0 is, okay? V0. Okay, use the position function below for free falling. This is another important part. If it says free falling, means you do not have any velocity, okay? That means free falling just means your V0 is 0. That's what that means. So this problem become a simple problem. They become a 0. Well, that is why your ST position function is negative 16t squared plus 1,353. So we got that. Take a derivative of that. Take a derivative of this. So derivative of this, just this one is what? Simply 0. We know that, right? I'm not gonna write down there actually. So, and then derivative of this is negative 16 times 2 times t2 minus 1, which gives you negative 32t. And derivative of this is what? Simply what? 0, because that's a constant function. So that's why you have this only. So A part is done. A part is easy, we're done. Okay, next one. Determine the average velocity of the interval between 1 and 2. So we know how to do this one too, right? So average velocity, we learned that means what? F of, in this case it's S. S sub 2 minus S sub 1. What's S sub 2? Let's figure out. S sub 2, which is equal to negative 16 plus 1353. What's that equal to? Calculator out. I could have used my Julia, but I'm just going to use a calculator for now. So 16 times 4 minus 1353, which gives me 1218. Gives me 1347. And minus 1289 gives me 58. Is it 48? Did I do something wrong? 16 times 4 minus 1353, 1289 plus 1347. This is 1347. Okay, so when you do that, you get a 1287. 1 gives you what? Negative 48. So that's why this is negative 48 per second. Okay, we got that done. Next one. Find the instantaneous velocity of t equal to 1, t equal to 2. We're going to use this function then right here. So v of 1, which is negative 32 times 1, which is negative 32. V of 2, which is negative 32 times 2, which gives you negative. Find the time required for the coin to reach the ground level. Okay, so that means the height used to be 1353, but now when you go to the ground level, what's my height? It is 0, right, class? So I'm gonna set S of t equal to 0 to figure out what the t equal to. It gives me 16 t squared plus 1353 equal to 0. Maybe I'll use different color. This problem now. All right, in this case, it's just an easy one because there's only 2 terms. So I move this one to other end. So I have a 16t squared equal to 1353. Everything divided by 16. So t squared is equal to 1353 divided by 16, giving you 84.56. And I'm going to take a what? Square root of that. So get a 9.196. I will use only positive one. Remember, time is only positive one. So that's why you have that. Next one, it says find the velocity at the coin at impact. So I'm going to V of 9.196, which gives me negative 32 times 9.196, which gives you negative 294.265 feet per second. I want you to go over this problem again by yourself, okay? Because when you do this homework problem by yourself, you will see there's some part that you may not understand. So you do it by yourself, make sure that you can do this problem. So there's another problem right here. You can do this by yourself and see whether you can do it. Right here. So everything, you will not have any problems in your homework. Okay, you should be all good. Okay, looking at this one right here, this one, you got two functions. It doesn't matter, okay? You can add them and subtract them, and you can multiply them, and you can divide them. That's what they're doing here. So this means f of x plus g of x. That's what that means here. I'm simply just doing a 4x minus 7 plus 6 minus x, which give you what? 3x. This means what? This means f of x minus g of x. That's what that means. What does this mean? This means f of x times g of x. That's what that means. So this just means you have to FOIL. Okay. You need to FOIL that. That's it. Okay, so over the domain. So when you do this problem, you get this 4x minus 7 divided by 6 minus x. You tell me which x can you not use and why. So f of x divided by g of x is equal to x minus 7 over. Tell me which. Okay, which x and why. I cannot hear you. Somebody tell me clearly. Well, right. Yeah, did you just say something? Okay, so this case, you're gonna put it to 0, then you can put it. So you know you cannot use x equals to 6. We're gonna say x. All right. With the negative, use every the negative union. I need to use. So any questions now, class? All right, so I go over all the homework, pretty much like all the homework. So class, make sure to do all your homework because you're gonna have over chapter 2 exam pretty soon. All right, and also